What's up everyone? Welcome back to my channel. So today we're going to look at the following calculus problem. So we're going to evaluate the integral of the following expression x raised to 2 times sine x power times the quantity of cosine of ln x plus 1 over x times sine x to the dx. So before we start the problem, if you didn't subscribe my channel yet and if you want to watch more of my videos, please subscribe and go to my channel so that you can find out more videos. Here we go. Now let's jump to the conclusion first. Unfortunately, this expression cannot be solved or expressed in the standard mathematical functions. In other words, this function will not be easily solved. And in fact, where did I get this problem from? Well, it was one of my subscribers who said that he got this problem in one of his exams back in the days. But if I'm not mistaken, there's actually a small typo in this problem because he told me that none of his classmates can figure this out in this exam. And in fact, he couldn't figure it out either. However, this integral can be solved easily by fixing one of the typos. Or actually, there's one big typo here causing not able to solve, which is this part right here, cosine of ln x. Because of this, we no matter what methods we use, such as the DI method or some other methods or U substitution, we still cannot figure out the antiderivative of this term. So to fix the problem, we just need to put the missing x here, which in fact means the product of cosine x times ln of x. So how is this going to help us solving this problem? Well, if this is the actual problem of the integral, then here is what we can do. So let's rewrite this part right here, the x to the 2 sine x power, into base e, which gives us e raised to the ln of x power times 2 times sine x, which is the same as saying 2 times ln of x times sine x. And then we'll still have the remaining part. And let me rewrite the order, getting ln of x times cosine of x plus 1 over x times sine of x. So, what can we do next? Well, the most annoying part when we're trying to do calculus, especially when we're doing integration, usually is if we see something that is not nice to integrate or differentiate. In this case, this part right here doesn't look nice. So what can we do? Well, let's do a U sub. Let U be equal to ln x times sine of x. This gives us du over dx is equal to, well, since this is a product, we need to now use the product rule. So it will become the derivative of the first part, ln of x, which is 1 over x, times the second part, sine of x, plus the first part, ln of x, times the derivative of the second part, which is cosine of x. What do we notice here? If we look carefully, we see that this part is exactly the same as this part, right? So this means if we take this part times dx, it will give us du. So with the substitution, we now get the following. We have the integral of e to the 2 times, now this part we said that is u, so we have e to the 2u power times this whole term turns into du. Now we just get the integral of an exponential function. So if we take the integral of e to the 2u power, we get e to the 2u, but don't forget the anti-chain rule. So we need to divide it by the constant here, 2. So we get 1/2 times e to the 2u power, and of course, don't forget the plus c. Finally, since we start with not u, but x, we just need to substitute back what u is referring to. So we get 1/2 times e to the 2 times ln x times sine x plus c. And this is the final result of this integral. Pretty cool, huh? So yeah, that's it. If you enjoyed this video, please don't forget to like. And if you have any interesting idea, you can leave your comment below, and I'll try to see if I can solve it and make it into videos. Alright, thank you for watching. I'll see you next time.